So, convolution theorem is given to the two functions merging for. So, convolution theorem, if Laplace inverse f1s equal to f1t and Laplace inverse f2s equal to f2t, then f into g equal to L inverse f1s f2s equal to integration 0 to t f1u f2 t minus u du. This is the statement of the convolution theorem. If we say that inverse of f1s is f1t, inverse of f2s is f2t, then if we are applying convolution, this is a definition of the convolution where star is a notation of the convolution. F star g is L inverse f1s into f2s equal to integration 0 to t f1u f2 t minus u du. Proof: f1s f2s equal to L f1t plus f2t. Okay, so 0 to infinite e raised to minus su f1u du, 0 to infinite e raised to minus sv f2v dv. We are taking 0 to infinity, it is e raised to minus s u plus v f1u and f2v du dv. 0 to infinite f1u integration 0 to infinite e raised to minus s u plus v f2v dv du. We are taking u plus v equal to t and dv equal to dt. So we get v equal to 0 and t equal to u. V equal to infinity, t equal to infinity. Okay, so it is f1s, f2s, integration 0 to f infinite f1u, integration u to infinity e raised to minus st f2 t minus u dt du. Now taking limit in the graphical formation, we are taking u equal to 0, u equal to t and u. There is a old limit and it is a new limit. Okay, so 0 to infinite u to infinity e raised to minus st f1u f2 t minus u dt du. To change the order of integration, old limit of t equal to u to infinite, but there is a start from the horizontal strips, taking u equal to 0 to infinity. So what is our new limit of the t equal to 0 to infinity? Then u equal to 0 to t. Applying this limit, we get 0 to infinite e raised to minus st 0 to t f1u f2 t minus u du dt. So it is Laplace integration 0 to t f1u f2 t minus u du. This is the formula of the convolution theorem. Find f1 star 1. First of all, f1u is 1. f2u, it is also 1. We are replacing, it is f1t, it is 1. f1 t minus u, so it is f2 t minus u, it is also 1. As per the formula, 0 to t f of u f of t minus u du. Okay, so it is 0 to t 1 du. So it is u 0 to t. So answer is t of the 1 star 1. Inverse Laplace transform, find 1 upon s square plus a square whole square using convolution theorem. See, this example is also solved by the partial fraction, but in exam paper setter are given instruction to find the inverse Laplace transform, this example using convolution theorem. Okay, so first of all, we are taking a two function. First one is f1u and f. Find inverse Laplace transform of 1 upon s square plus a square whole square. This example is also solved by the partial fraction. but we are solving this example using convolution theorem. First of all, we have to find two functions. One is f1u, second one is f2u. f1u is 1 upon s square plus a square, f2u is 1 upon s square plus a square. See, multiplication of these two functions is 1 upon s square plus a square whole square. Now, to find f1t, what is f1t? f1t is 1 upon a sin at. Similarly, f2t is 1 upon a sin at. But in second function, we get f of 2t minus u. So, it is 1 upon a sin a t minus u, and this is f1u, so it is 1 upon a sin au. We get two functions. Okay. Now, what is the formula? Formula is 0 to t f1u f2t minus u du. 0 to t. What is f1u? 1 upon a sin au into 1 upon a sin a t minus u du. Okay. Taking 1 upon a common, 1 upon a square. Taking 1 upon a square common, 0 to t sin au sin a t minus u du. Multiplying 2 and divide by 2, we get 2ss rule. What is 2ss? 2ss is cos alpha minus beta. So, au minus at plus au minus cos au plus at minus au du. Okay. So, it is 1 upon 2a square 0 to t cos 2au minus at minus cos at du. Taking integration, 1 upon 2a square cos 2au, so it is sin 2au minus at upon 2a, coefficient of u, minus cos at is a constant with respect to u, so it is u cos at. 0 to t. Upper limit minus lower limit, we get sin 2at minus at, so it is sin at by 2a minus t cos at. Applying sin 0 here, sin 0, so it is lower limit minus, and due to odd function of minus, it is sin at upon 2a. And it is 0. 2 sin 80 by 2a, so we get 1 upon 2a square as sin 80 upon a minus t cos 80. Okay. One upon 2a square sin 80 plus sin 80, so it is sin 80 by a minus t cos 80. The last answer. So this is a convolution theorem. Next example, find inverse Laplace transform of 1 upon s square plus 4. f1s is 1 upon s. f2s is 1 upon s square plus 4. Now f1t, so find the inverse. It is 1. f2t is 1 by 2 sin 2t. As per the formula, we take f1u is a 1 and f2t minus u, that means 1 upon 2 sine 2 t minus u. If you want to take f1s equal to 1 upon s square plus 4 and f2s equal to 1 upon s, then it is also soluble by this form. So what is here f1t? f1t is 1 upon 2 sine 2t. Here is f of t is 1. f1u 1 upon 2 sine 2u and f2t minus u is 1. So it is easy to solve. Now if we are applying 0 to t, f of u, f1u, f2 t minus u du. We are taking second pairing. So 0 to t, f1u is 1 upon 2 sine 2u, f2 to u is 1 du. 1 by 2 sine 2u is cos 2u by 2. 0 to t 1 by 2 minus cos 2t plus 1. So answer is 1 minus cos 2t by 4. Okay. So this is the answer of the example.